Welcome to Rubber Duck Engineering. Tonight is the dramatic conclusion to the wave function collapse. Good evening, Dr. Barth.
Hey, Eric, either we're going to collapse the wave function or we're going to collapse some exhaustion. Is that the plan?
Or maybe a little of both.
Do you want to get the audience back up to speed? What is wave function collapse?
Oh, wave function, yeah, bring people. It's a fancy name for a process of elimination algorithm to generate either 2D or 3D terrain that is used in a variety of games. It does a nice procedural generation where it, from a tile set with known allowed adjacencies, picks a random tile and then looks around near those and be like, oh, what of the remaining sets could go here? And picks one of those. And then it just slowly fills in the map that way, or quickly fills in the map that way.
All right, and this is episode 3, and we've gotten most of the structure in place, but we've written a bunch of checks, which takes the form of functions whose signature and semantics we've decided on, but we haven't implemented yet. And so we have sort of the core algorithm going, but it's calling these magical functions that currently are empty, that we'll have to fill in order to do something useful.
Great. Just to check, your video and audio seem a little out of sync.
Yes, it's lagging. Let me try. I'll leave the broadcast and come back.
I will get to the code machine while you do that.
Excellent.
To the code machine. Do. Yes, and as Dr. Barth said, we wrote a bunch of checks, which is we are wont to do in this show. Where was it? We haven't actually looked at this code since we saw you all a week ago. I've been a little busy. We've been a little busy. I see. We wrote constrained neighbors and get maximally constrained position.
Thanks for joining us. Thanks for the vibes. I appreciate it. Yeah, collapse I think was the main, that's like the core of the algorithm. And then
yes. Yeah, we wrote out what the algorithm should be. Right. Pick a random tile. Get maximally constrained position. Oh, will this just pick a random one when there isn't one?
Yeah, I mean, it's going to have to do something, right? If there's a tie, it'll have to break the tie somehow.
Yeah, okay.
I think we should start there, because that one I have a pretty clear idea. Sure. Eventually we're going to get down to this. We have this adjacency oracle, and then eventually we're going to have to figure out how to implement the adjacency oracle, which is going to be the hard part. So I kind of want to save that for last.
Okay. I think it was you who taught me the oracle term for these sorts of classes some decade ago.
Complexity theory, where you want to say, suppose you just had somebody who could answer these questions for you, what could your Turing machine compute now?
Yeah, and it works great for this sort of check writing. You just imagine your oracle and someday make it work.
All right, so this is gonna be pretty easy. We got to iterate through all of our things. Start from 0. Oh boy.
Is the code lagging too here?
Oh, no.
I'm happy to help type.
Yeah, go for it.
Okay. Let's see what I got. This is from Possible Tiles? Yeah. Wait, yeah, this is from Possible Tiles. Oh, I see we have Python on this thing. Yep, okay. And then we're going to go for... This is where you really want a for each. This is what grid was good for.
You want me to write the for each?
It's okay. Eventually you will come to believe that grid was a useful class. We will resurrect it in our future, in our third project, where we have to have an arbitrary
2x2 array of things.
2x2 and don't want to remember whether it's Y or X first.
So I think on possibility, we should have how many possibilities.
It has a length or whatever.
Yeah,
sure.
It's trivial. So now we have that. So the var best count.
All right. So best location. Okay. So if best location is equal to null, or let's see what. Thank you, Copilot.
Thank you. Copilot does it again.
I love it.
Good job, Copilot.
Okay. It's so good at this. I've been using Copilot a bunch this week.
We do have to return from the bottom of the function. Copilot will not apparently remind us that we have to.
I'm still reviewing its code here. Okay, so yep. Okay, and then we do. Oh, this is not what we want though.
What's wrong with this?
Well, this is going to pick the last one, so we're always going to start in the lower right hand corner.
That's fine. You want to collect up all the ones of the current count, so like that's fine. You could just have like a list, right?
Oh, you know what?
That's right. We should pick a random one.
Special case, that specific case.
No, I think we should pick all the ones of that are maximally constrained, and then pick a random one.
Okay.
It's like if this is empty, or then
yeah, this is not going to be true in the null case, but yeah. We're going to have to empty this whenever the count changes.
Right, so there's two cases, right? If it's equal, if it's empty, then we'll just record it, right? Best locations, add the location. Best count is the best count. Okay.
Yep.
Otherwise, there's something there. So if we match is equal, then add. And if it's less, yep. A better one. Then we need to also clear it and add it. Yep. Looks good. Locations. Okay. And then at the end, we want to pick a random one, right?
Why is it not formatting? Something we're missing. Yeah, we need like more. Yep. Otherwise, we return. Okay, and this should probably take a random, unless this thing has a random. It has a random. Okay, great. A render UI kit view. What?
There we go.
Really?
Okay.
Yeah. Copilot did it, but you really want like a pick class. Pick one. Not a class, but like an extension method kind of thing. It's kind of when I used to write Objective-C many, many, many years ago, you would have this like set of private extensions that you would like cart around from project to project, which are your like. I suspect people who do Flutter who like write Flutter apps for a living do the same thing.
I should have like a random on list because you just use that all the time.
Correct. Maybe not that
like
specific one.
It's like your Vim RC file or like your Emacs environment that you've like perfectly customized to like fit exactly how you want to type things.
Well, they were just. I remember. I think it was like Objective-C array or NS array didn't have a like first method back when I was writing it. I think it grew one later, and like you just always want first instead of doing first and last instead of having to look up the length of the array and doing the. I think it grew one later. This was a long time ago. I joined Apple shortly after macOS 10 came out.
Okay, so I think we've cached that check. No, the opposite of that. We've made good on that check.
Yep, I think we have. This should be reasonable. I mean, we could test this, but
okay. So constrained neighbors, we're going to need a queue of like modified locations.
And here again, you want the grid.
Do we?
What? Grid has 4 each neighbors, but it's fine. What do you? Oh, I see. You're right. Oh, wow. We have like a recursive algorithm here. Or we could.
Well, it like propagates, right? It's like a propagating algorithm. Right? We have this first modification, then we need to like basically do a BFS or some kind of search to as we change things, then update all the constraints around it. This is like
I feel like there are algorithms that do exactly that. Like I can think of, like a dumb way to do this would be to just every time you change a location, you just call constrained neighbors on that location.
Pilot is suggesting this enormous thing. I just put in here for fun to see what it is.
While modified non-empty.
Okay. Remove the location. Yeah. Possibilities. If it's resolved, continue, right? There's no point in doing anything. Otherwise, get the neighbors of that location, which is logical. For each neighbor, get the possibilities. If the possibility... Look, it's like plausible. Like I don't even know.
Why does it keep checking to like...
Okay. But this is... We also need visited, right? Because but we keep changing things. Like, how does this thing ever stop? Like, I guess it'll stop modifying things at some point. Because whenever you modify, you need to go recheck all the neighbors to like update their constraints.
Well, you only ever reduce the number of possibilities. You only ever rule out. You never rule in, right?
That's true. So it will eventually stop.
The other thing you could do is you could just have a global algorithm that walks all. You could just walk all the neighbors of the current like map, or some nearby, and just constrain them. You never have to propagate.
Well, you kind of have to go back, right? Because when you remove a possibility, let's say you're going to go in row order, right? If you remove a possibility here, you might have to change the constraints on the previous row. So you're going to like wander around the map, right?
You can also do just a global walk until nothing changes.
Or just like scan it in order.
Yeah, you can just scan the whole map.
Until nothing changes.
Or some locality, right? Like within X, just...
That's true.
Draw a bounding box around your thing, scan all tiles. Like for a given, like at a given place, you can look at all of the things around it. And
let's write get neighbors, because get neighbors is going to be looking. I think we could do it this way with the modified, the pending set or whatever. 6R. While going to do this for me.
It may not understand sync star.
UI is less than or equal to. We don't need to do the this is or, right? Because we only need we don't want the diagonal neighbors.
Yeah.
Yeah. So this is get neighbors. That looks pretty good. X, Y, X is less than the width. You have the location. Okay. So now for each neighbor, I think we need a function that's like constrained tile or something. This is resolved doesn't make sense.
Well, again, looking at a given location, you can just have it look at its neighbors.
Right. So this is like pending, like needs. This is like pending, right?
Yeah, needs eval or whatever.
It was really when we changed location. So really, we want to add all of the get neighbors of this location. So these are all things
resolved. But yes.
Oh well, if they're resolved, we'll just skip them. That's not so bad.
Well, we could also just filter that, right? But yeah, that's fine.
Okay, so let's have a get unresolved neighbors. I think that's good.
Okay. Interval.
Okay. So get all the unresolved neighbors of this thing. Okay, so now they're pending. We want to pull our pending location. We'll remove it from the thing. Great. So it can never be resolved, so we can get rid of this.
Okay.
Okay. I'm just going to delete this Copilot code. We may end up just like retyping it, but that's fine.
That's fine.
Okay. So now we need a function that's like make this correct, like rule, like we want to compute the correct set of possibilities for this location.
Mm-hmm. Yeah, I think you just want to like, where do we?
It's almost like set at, or like this is like the original.
Well, the set of possibilities will never be larger than it currently is.
So we can just look at each one and see if it's okay.
Yeah. Wonder if there's a DFA equivalent with no backtracking. There's that.
Good question. I think you have to backtrack, because if you ever make a change in any location, that could affect what's allowed at previous locations you've visited. So anytime you change anything, you have to go visit all of the unresolved neighbors. I could be wrong, but that's my intuition to it. So we need to basically do this. We need to say like for...
Yeah, you want to check each of the possibilities and see if they're actually still valid.
In possibilities dot possible
It's like
tiles,
validate possibilities or something like that. Mm-hmm.
We want to say if not is valid at location tile, rule out that tile.
Yep.
Okay, and then I need to like
more checks.
And then I need to keep track of like, did I change anything? I want to say like rule did change, did rule out tile, did rule out possibility, false.
This is not right.
And then I totally ruled it out. So I'm going to say true. And then after we do this, we say, if we rule out a possibility, then we need to go add all the unresolved neighbors. Hey, Tuck, thanks for joining us. We're working on a wave function collapse.
Neighbor, possible tiles. No, this isn't. None of this is right.
That's not. So we have the oracle. So now we need to pull in our oracle, which we don't actually have on this class yet.
Did we write an oracle here somewhere?
Somewhere, if you scroll around, you'll find an oracle.
Neighbor oracle can be adjacent. Oh.
Yep, that looks like kind of what we want, right?
Oh, yeah.
So the wave is going to need an oracle. We're going to get it.
Folks watching, as they're just as lost as I am. Okay, here, I'll jump to you.
I gave myself a neighbor oracle out of nowhere.
Okay, yeah. So return neighbor oracle.
Well, again, we need get neighbors again, right? Because we need to check for each. But we're going to need it with
unresolved neighbors?
No, you want all the neighbors, even the resolved neighbors.
Yep. Get neighbors. Yep. Get at. Yes.
So what is the oracle giving us?
Oracle. The oracle, you asked it. I'd have to look.
The oracle may not be set up quite correctly.
What's up here? Okay. Oracle can be adjacent, left and right.
But left and right is not enough, right? We need like up and down and left and right. So maybe we need to pass in like a delta.
No, well, I see. We have to.
There's like horizontal adjacency and vertical adjacency, right?
So the way the XML is specified, it's all left and right adjacency. but then you have to undo the transform in order to get back into that space.
Yeah, so I think that should be the neighbor oracle's job. It should hide that in its implementation and give us a slightly more ergonomic API.
Okay, so can be left, right. What?
Yeah.
Can be
Up, down, or something.
can be top, bottom.
Sure.
That's it.
And then the arguments need to be top and bottom instead of.
Fine.
Okay, so let's go from there. That seems legit.
Except your neighbor list is now going to get you in trouble. You're going to have to figure out which direction they're in.
Right, so let's make an enum that's like direction adjacency. Adjacency.
I mean, we also could just have a thing that like turns them back into tiles and like what does oriented tile have? Oriented, I see.
Yeah, I think we should keep going for a little bit. So like, well, we can pass in the adjacency direct. Well, okay.
Well, I mean, we could have our neighbor thing, walk through and tell us which, like, give us a neighbor pair class that like tells you the direction of neighborness. We could also transmute the tile. Oh, but
Let's just try it. Like, I'm a little bit unclear what we're gonna need here. So like, my dx is that, and my dy is similar. I know that like only one of these can be non-zero.
mm-hmm.
I can say, so if dx
It's not equal
greater
to
than
0.
0,
Okay.
not equal to 0,
Oh, I see.
then it's a left-right case, right?
Yep.
Okay. And I need something similar for y.
Well, in fact, we have to do all of the cases because it matters which one is left and which one is right.
I see. So you just want to do all the cases. So you want to say
Yeah.
if dx is equal to 1. Okay.
Right.
Yep. Go for it.
Whoa. What Copilot tried to do. Then we want neighbor oracle.
That's not quite ready there. We have to look at all the possibilities too.
I think Switch is gonna. It's right. So I'm sorry. We are calling.
Let's just do, yeah, this is a little bit tricky, but I think we should try to just do the simple case first. So let's just say if dx is equal to 1, let's try to write the code for that.
Okay.
So then we need to iterate through all the possibilities.
That means that neighbor is to the right. Yep, that is correct, Copilot.
So we need our neighbor possibilities. We're just looking for just any match between oriented tile.
This is part of our problem.
Is valid at location. This is also possibilities, right?
Why is it mad? My app isn't a class. Something got confused up here.
Oh, no, this is an actual tile.
Some sort of we have like a stray. We don't have something that compiles, and so it's sad life.
So we need to iterate through all the possibilities.
I'm trying to fix the syntax error so that the Dart analyzer will be happy with us again.
Okay.
So can you get to a stable space?
Yeah, this is a stable state.
All right, yeah, Somebody's really mad at life.
Did I screw up when I made the oh,
I don't know. I mean, it must be early in the file, but I haven't
how
found
could-
it yet.
how come my app isn't a class?
Yeah, well,
oriented tile got removed. Oh no, it's down here.
well, that's probably like right where it's like it got screwed up here. Like you probably have this collapse probably has an extra. No, those
Extra
are
curly
correct.
brace or something. Find the missing curly. Oh, there's a missing curly brace here. That fix it?
Yes, peace and justice is restored. Okay.
Okay. Well, one
Now
missing
we
curly
have
brace,
Oracle.
and the world came to an end. All right, so this
Yeah,
this
it
is
was
one here.
it was very very sad at life.
Okay.
Okay, body might complete normally is valid location. True and false.
This is
Okay.
like neighbor tile.
All right, now we have an analyzer again.
And we somehow want to ask the Oracle if neighbor Oracle, but this is now left, right, and the neighbor is on the right.
Can be left, right, but I can change it. Is valid left, right? Yep.
And which side is the dx is 1, which means the neighbor has a greater value, which means the neighbor is on the right. Assuming we increase in value. Yeah. Okay.
Yep. That's what this comment was supposed to help you with.
Okay, great. Oh, it was below, so I didn't see it.
Yep.
So we don't want to return true here. So if
is valid at location. Wow.
return true is not the right thing here.
Why are we walking through every neighbor? I'm sorry.
I think this is continued because there's a possibility, right? If the neighbor gets resolved to this, then this neighbor, the constraint with respect to this neighbor is fine. All right, so we can go check the next neighbor.
So, okay, is valid at location.
We have to go check every neighbor to
Given
see
a
whether.
location,
Yep.
check to see if you put this tile there, that would still be allowed.
Right, and allowed means there's some possibility for our neighbors that would be valid, a valid adjacency.
I wonder if we're doing this right.
Well, that seems legit.
Like another way to do it would be to compute, like to walk the possibilities of a given tile, of a given location, and constrain all the neighbors based on those possibilities.
Oh, like intersect them?
Yeah, it's like you just take your possibilities and you hand them to your neighbor and say, constrain yourself with these from the top.
Mm-hmm.
That feels like, I guess that still is the same amount of work.
I think it boils down, you basically have to do this check. I think you end up like the search ends up a little bit different, but it ends up being it's not going to be, certainly not asymptotically any faster.
This just feels wrong. I'm not sure what right is, but.
So my experience is when I've rewatched episodes of this show,
yeah,
whenever you say something feels wrong and I like bulldoze you into doing it my way, then like half an hour later we find out that you were right and I should not have bulldozed you. So this is my attempt to now not bulldoze you and hear you out. So
we're gonna set a timer. We're gonna breathe.
We're gonna breathe. Let's take a couple minutes and.
So what? It just feels wrong that we're like iterating the neighbors to go look at each location and then iterate the neighbors again.
That's true. So that is wasteful because if we're rechecking a bunch of neighbors that haven't changed, like let's say we change here, right? Then we go next door. Now we're going to check 3 other things that haven't changed. That's wasteful. I totally agree.
So help me think through say you walked through each tile, you grabbed its possibilities and you shoved it at all of the neighbors. And then I think there would be like some quick cases from that. Like if you're ever handed an all possibilities, you just be like, ah, no work. You're not constraining me. Fine. And if you're
Well,
ever
I
handed
think-
an empty
you might-
possibilities, you're like, oh, or like a resolved one, you're like, oh, okay, this is the only thing that's allowed.
I think you still want to do this kind of loop. This kind of loop seems fine, but we just want to reorient the loops a little bit. So let's go back to constrained neighbors and see if we can do it a little bit differently.
Okay.
So let's change this pending back to modified.
Okay.
Right, is what you were saying. Like, let's visit every time we modified something. We're just gonna add the location we modified. So let's try to do it by walking the neighbors of the thing that we've modified. So if modified is not empty, pull out the one we want. Okay. And here are the possibilities here. So now we need to go visit each of our neighbors and check that, like, see if we need to constrain them. Like,
You're
change
basically
something.
notifying them. You're like, my possibilities changed.
Right.
I mean, you could even further optimize. And if you understood what the change was, like the delta, you could just say these possibilities are gone. I don't know if that helps you actually, though.
I'll just get all of them. Okay, so right for these neighbors, what do we need to do?
So to complete that thought, if we pause for a second.
Yep.
If we were sending a fully reified is the word that comes to mind, but it's not correct. But like if we sent a full diff, and we said, "Hey, we deleted these 3 possible tiles from us," then all of our neighbors only have to check to see, do any of my current possibilities depend on that tile being in this orientation from me?
Yeah.
And if they do, they rule out those, and then they propagate that same. I just ruled out these. It's like a did rule out notification to your neighbors.
Yeah. I think that could work too. I think this seems easier to not do the diff version, just do the validation version.
All right. Anyways, that becomes very, to finish that thought, that becomes very small very quickly, because the did rule, whenever did rule out is like nothing, and it's a no op, and you just stop propagating.
But that'll happen here too, because we're gonna see if we modified it all. So when the diff becomes 0, we're gonna cut off the propagation.
Yeah, so this is very similar. It just doesn't include the diff. The neighbor that you're notifying has to compute the diff, or just has to recompute from first principles. And then if it changed, I guess should save its its previous state, and be like, did I rule anything out? Okay, if I didn't rule anything out, then I stop. All right, that's fine. Okay.
It's Copilot is getting excited about this function we half wrote and it wants to call it, even though the whole point of what we're doing is to not call this function.
All right, so we changed this one, so now we have to look at all of its neighbors, and for the neighbor, we have to check their possibilities to see if they're still valid.
Right, we need to look at the full matrix of possibilities.
We changed. Let all of our neighbors know so that they can confirm their are still valid. Okay.
Every possible thing that the neighbor has, we need to check all the things that.
So like this could be this itself.
This is it.
If you hold this up for a second.
Yep.
This then becomes bool did change equals neighbor dot validate possibilities. Oh, or maybe that's a. There you go. And then this function is just that.
Correct. That's sort of what we wrote before.
Oh,
but,
you're writing something different now?
Well, the reason we didn't like this is because when you asked the neighbor to validate its possibilities, you lost the what thing had changed, and so you're going to check all 4 adjacent things instead of just the one adjacent thing. But roughly this. Do you mind if I comment this out?
Yeah, please.
But I think that this code that mostly Copilot wrote is correct. Well, let's look at this. So these are the neighbor possibilities. We look at each of its thing, and we want to check, like, is this tile still possible? So we go look at all the possibilities that are where we are. If this is this is the wrong adjacency, but like, if it's valid to be there, then that tile is fine. We can keep going. We need to break out to this loop, actually.
How is this different than what we wrote before? I mean, it's fine. I'm just, how is this different? We're just inlining this function, right?
The difference is before we were going to go visit. We were going to go visit all 4 neighbors and check in all the possibilities. Now we're only going to visit the edge from the modified tile to the adjacent tile. Before we said every tile is adjacent to a modified tile. Go recompute from scratch what's possible for you. Now we're going to say, okay, look at this modified tile, check all of the adjacencies, and update the neighbor. No need to apologize for being late. You can come hang out whenever you like. Thanks for coming.
Yeah, I'm not sure I followed. You're saying that we're going
to... They're very similar. Like the approach we were using before, I think would also work.
Like, is this even, like, here we lose the adjacency information between this neighbor. I see the neighbor is a position.
Mm-hmm.
I see. So we have to compute that. Why don't you just keep going? And I
mean, we can compute the adjacency here, right? I feel like I tried to accept your suggestion, but you became sad.
Oh, I'm not sad at all.
Okay.
I wasn't following exactly. So
we try to make a diagram. Like, I feel like this is, maybe that would help understand what's going on. No, I'm sort of spamming out these cases.
Mm-hmm. Go for it.
Okay. This continue is not quite right. So if dx is 1, this is the other way around. Oh, no, this is right. Okay.
I mean, we also could just throw that in class, honestly. I'll make you a class to do that simpler.
Okay, thanks. This
You're typing away off screen.
I finished typing.
Oh, you're now watching me. No.
I mean, it would really help me if this class could call the Oracle for me. If I could just like say is valid and pass in my 2 tiles and have it call the Oracle.
Well, I was doing the like and then I was going to do this here, which is cool.
Oh, I see. Yeah, that's super useful.
Yeah,
I'll make use of that class. Now I understand what you're doing here.
It was just that you had to like retype. I just knew we were going to get the logic wrong. We were going to swap which one was. My spidey sense was going.
That's exactly what I want. But I need the tile too.
Oh,
I'm going to call the oracle with the tile.
is this not helping you?
Well, it's helping me. You're just keep going, and then we'll see how to use it when we get there.
Come on, Copilot, you can do it. There we go. This isn't quite right. Left is X is positive. Top. Should really assert. That's what I should do. Let's see, probably gets it right.
No, it flipped the second in first.
Oh, it did.
Yeah.
Oh, it. Go Copilot. Go Copilot. There we go.
Okay. So this is great, except it's not quite what I need. So I think if you go look at where this is used, no, it is good. It's a really good idea, and it's like 90% of the way there.
Okay.
So go tell me how to use it.
Oh, tell you how to use it?
Yeah. So I created the relationship.
Oh, you just
And I
do.
said,
Oh, you want to iterate over not the tiles, but the positions.
but I have to iterate over the tiles, right? Because each position contains many tiles.
Oh.
Yeah. So that's okay. You're. I think what I want to do is I want to say like, left.
Yeah, I mean we
both
could.
tiles, right? And then I want to say relationship.right,
Oh,
and also passing both tiles.
sure, that could work. Yeah, it's a little. I mean, yeah. It's like enumerate, right? In Python, you want the index to come along. We could have a located tile.
It's fine, but I think this will. Yeah.
Okay. I am on it. Why did that not work?
Yeah, that's exactly what I want. I'm just going to delete your old left and right ones.
Well, but this pulls from the arguments rather than the.
Yeah, this is good.
Oh, I see, because you never use them.
This is what I need.
Copilot, you can do it. I believe. Copilot and live share just do not like each
Oh,
other.
sorry. I'll move my cursor farther away so it doesn't fight with the.
I actually don't think it's your cursor per se. I think it's just something about like the, oh, maybe it's your system auto formatting in response to the change. Somehow,
they're both manipulating the buffer and it's messing with it.
yeah. All right, did it work? Let's see. Left. Second first, yeah.
I just need is valid up down to be a thing. Oh, top bottom. Okay. Great.
Okay.
I think if we had an oracle, then everything would work.
That can't be next episode because we promised. So what do we need the oracle?
I think we're down to the oracle.
Okay, let's do it.
All
We're
right.
locked in the room with the oracle. Oh, whoa, we got. What is this?
Okay, yeah. So that was a little fancy. I think that is what I needed to do. So let me talk through it. Let me try to verbalize it.
That
And
works. Are you sure? I remember breaks sort of work in Dart like I expect them to.
Or you want to just go to?
Mm,
I don't think Dart has go to. Yeah, Go doesn't have go to.
You can like break to a label, but I don't remember where. There's very few places you're allowed to put the label, and I don't remember where they are. Maybe it's right before the loop. Oh, it is exactly for this. It's for breaking out of a nested loop.
Yeah. So what's
Okay.
happening here is, so if I find a tile with a valid relationship, then I'm done considering all the possibilities.
Mm-hmm. Mm-hmm.
No, that's not true. There could be more
You're going to
possibilities.
also add the neighbor twice to modified.
That's fine. It's a set. It can handle that.
It's a set?
I want to go here. Next neighbor tile. That's what I want.
Because our turducken loop here.
We have a triply nested loop. So as soon as I find a valid possibility,
Is there a score multiplier applied? Should we get the triply nested loop correct?
this is why you want to make subfunctions. So I guess I can, if I permute these loops, then I don't need this fancy break statement. Okay, this is correct. Okay. I messed it up. Go back to where I had it. Yeah. Okay. So I'm trying to figure out, like, is this tile, do I need to rule out this tile? So if I
For a given neighbor tile, we iterate our tiles. And if we find a valid, if it's
a wild
valid,
turducken chase, yes. a turducken loop.
yes.
I'm certain there's some way of dividing this into functions that would make it way easier to read.
Turduckens were like totally a thing 10 years ago. It was like a very brief, just like deep frying a turkey. I'm a little off topic.
I think we should break this loop out into a function. That would make our lives way easier to understand.
Okay.
Should we attempt that?
Yeah, go for it.
Okay, so it's like bool. Is valid. Is possible tile. Is valid tile.
And then you pass the relationship and then the
Yeah, I need to pass the relationship.
The tile and the neighbor tile.
Yes. Relationship. The oriented tile. Tile. And then I need to pass.
We're going to end up collapsing the relationship onto the tile because the oracle's going to want it, but
yeah.
But it's okay.
These are like the neighbor tile, right? Yeah, this is the neighbor tile. You never want these like crazy triply nested loops and like
Nope.
break out whatever, like
You do not.
breaking out for the so the whole point of this is we return true. We have succeeded in validating this.
So is this is valid tile or has valid tile? Or oh, I see. This neighbor tile with these possibilities. Okay.
Why is this the neighbor tile? Yeah, this is my neighbor tile in this relationship.
Mm-hmm.
And
here's my possibilities.
Here are my possibilities. Can this neighbor tile? So it's like is valid neighbor tile.
And really, this goes on the thing that has the possibilities.
Yes. We're gonna need the. Yeah, this is a function on possibilities.
Okay.
We're gonna have to pass in the oracle. Right, you moving it? Go. I don't want to edit it while you're moving it.
On it. So on it.
This is like designed by refactoring. You write this like horrible code, and then you figure out like conceptually what is going on here.
Well, and this is also why you and I work in typed languages, is because we have this coding style. Like you cannot do this in an untyped in a duck typed language.
You need the oracle, right? The neighbor oracle.
And why you can't do it in a duck typed language is because you end up always missing something.
You can never put it back together once you've broken it.
Well, yeah, this is why you have to unit test it. 100% unit test coverage if you're in a loosely typed language.
Okay, so let's see if this makes sense, right? So is this a valid neighbor tile? Here's your neighbor oracle. Here's your relationship. And here's your neighbor tile. That makes sense. So we go iterate through the possibilities. And then if it's valid, we return true. Otherwise, we return false. That's a totally sensible thing. Okay, so where did we break? Where did we take this loop out of?
Here. Somewhere here.
Line 180-ish.
Yeah, like 182, I think. This?
Okay, yep, great. So if not possibilities is valid neighbor tile, then we're going to rule them out and say that we modify the neighbor. We're going to pass in the oracle in the relationship.
This like code actually looks like it makes sense.
That's dangerous. That's part of me is full of bugs. Okay, so for every neighbor, we look at the relationship, we get their neighbor possibilities. So this we can just do, don't need to variable for that. We look at all their possible tiles. Oh, we do need that. Okay, fine. We look at all their possible tiles. We say, if it's not a valid tile for the neighbor, then rule it out and remember that we modified the neighbor. That seems legit.
Where's our tile in this? I'm sorry. So, okay, for each of our neighbors, we establish our relationship. For that neighbor, we get all of its possibilities. For each of those tiles, for each of the possible tiles, we then ask our possibilities.
Yep.
Yeah, we ask our possibilities if this relationship to that tile is possible. If not, we rule out the neighbor.
Yep. And we keep doing this until we stop modifying things.
Convoluted, but yeah, okay. This seems fine.
Okay,
so are we gonna attempt for the oracle? The triple Lutz?
We gotta attempt the oracle. Sure.
I mean, otherwise we've just written checks we never intend to cash.
We've reduced it to the oracle, which in complexity theory means you've won. You've proven your theory. In software engineering, it means your thing just still doesn't work.
QED.
QE. No. Reductum ad oraculum.
Okay. All right, so we have to like somehow
All right, so we should go back to where we're parsing the
Convert
XML.
this
We need to-
into a left, right, validate
Right.
against known allowed relationships.
Right. So if we go to line 300, here's where we need to create our oracle. So let's create our neighbor oracle.
Mhm. Ah.
Okay. And now we're reading this XML file. We got to figure out what to do.
Well, it occurs to me we can just use lots of space. We don't actually need to do any like conversions of the thing.
Yeah.
We just,
You got
as we're doing it, we just spam out all the possibilities.
Okay.
Like the oracle will end up holding a giant set of possibilities, but that's okay.
So
We
let's
just basically check.
So great. So join me on line 300, and we'll try to construct this oracle.
QED.
QED. Okay, so let's ignore the number. Okay, so we should refresh what these things look like.
Oh, we got to go find the XML file.
I'll just paste an example into here. So roughly, this is what the XML file looks like.
Oh yeah, but the numbers end up all wacky.
Okay, so we need to decode this name into an oriented tile, right?
Yes.
Okay, an oriented tile is integer based, right? Let's go see.
Yeah. So where is the
It's integer based. That's good. Okay,
integer,
so
it's a tile ID and an orientation.
right. So we need to split this thing on a space.
Well,
to figure out.
This is a separate function, man. But yes.
Yeah. So let's write the function that
we
parses
do-
this thing.
If you get oriented,
Yep.
oriented tile by name, or something like that, right?
Yep.
Okay, and so then on this thing, oriented tile by name, string name. Right. Okay. So we do. Oh, thank you, Copilot, or lack thereof. Okay.
Copilot is gonna have no clue unless it knows about this.
List
Who
string
random.
parts equal to name.split.
Mhm.
Okay.
I'm gonna create
do-
a tile ID by name.
If
Tile
parts.
ID by name.
parts dot length is equal to 1, then we just do return get tile. What's the ID? But wait, can we just get tile by name?
Get tile ID by name. Pass in the parts. 0. And the orientation is normal or whatever.
Part 0, yeah.
Orientation rotated 0. Okay, legit.
Yep. Okay, that was a simple case. Right, and now we have to go look up from their code. Right, they have the first 4 are, or did we do it in the same order?
Let's assume we did in the same order, and that'll be the last bug that we fix.
Great. Well, this bug will manifest in craziness, in look confusing. Get tile ID by name.
Orientation.
Tile name.
Index.
XL. Oh, this is get tile ID by name. Yeah.
Okay, parts 1. This is like int.parse. Okay, and then we're going to return oriented tile by name. There we go.
Well, so hard.
Yep. And otherwise, we're going to throw invalid tile descriptor. A name. Identity. Okay.
Okay.
This is good. So we got the left and the right. And now we need to add these to the oracle.
Great. That's
Add valid left.
but then
right.
there's like a symmetry thing.
But we can do that on lookup, right?
Because each tile has like symmetry information.
Oh, the symmetry information. Yes.
Where was that?
It was here in the tile XML. We didn't record it when we parsed that part.
That's fine.
So
We can just ignore it for now.
Well, we can just keep a list of symmetry
For the given tile.
Well, for the did I spell symmetry right? No. We'll just keep it for the index, right? Add. We need to parse the symmetry.
I'd have to go look at the like.
Well, let's skip the symmetries for now. But let's write to do symmetries.
We're not. It ain't happening in -1 minutes.
Yeah. Do chord symmetries.
I'm gonna build this thing.
Well, we don't have valid left right yet.
Add valid left right. Oh. Whoa. Yeah, because we'll have to like add all the rotations of that left right, or just the left right and the top down. Okay.
Yeah, because it's really complicated.
It's okay. I think so. If we just did, if we just had like tile pairs.
I just created this allowed adjacency class. Do this.
Good.
Yep. Where's the oracle?
Okay. Allowed adjacency. Yep.
Mm-hmm.
Left, right. Left, rights.
Yep. Let me say. Well, we only need left rights. Just adjacencies.
Oh, because we're just gonna transform. Okay.
I think we're gonna stop because we're running out of time, but we can talk through the rest of it.
Well, this would need to rotate both tiles to their left-right forms and check.
Correct. We somehow need to. We could implement. We could try that. You can implement is valid top bottom in terms of is valid left right by applying a rotation.
Both rotations must be checked. Right?
No, you only need to check one of them.
Do you need to rotate just 90 degrees or also 270?
Just 90 degrees. We'll have the left right check both possibilities. Because they're top bottom, you just need to rotate them to be left right. And then if you have an answer for left right, then you can return the answer.
Okay.
So there's a bunch of like rotation logic that we need to write about, like taking an oriented tile and rotating it by 90 degrees. And this like wave function collapse thing turned out way more complicated.
Well, I mean, some of it is we didn't do anything in the Easy Bake Oven, right? Like we followed the original rules of the show and we didn't do anything during the weeks. We've both been a little busy. But I don't understand. It seems so much deeper, so much harder than I initially thought the problem to be.
Well, all of it is in this like geometry working, right? Let's say we had a bunch of like geometry primitives, like rotations and tiles and angles and all that stuff. Then all the rest of this would be like the algorithm itself is quite simple. It's just managing the geometric information that's tricky.
And I just wonder if we could have managed the geometric information with space instead of time.
Mm-hmm.
Right? If every time we saw one, we just splatted. We're like, we will record all 64 possible orientations for each thing. Great deal.
Mm-hmm.
Like I feel like there's a whole bunch of space optimization that was inherent in the thing that we read, and we've, I think, typed in a bunch of space optimization, which has made it harder.
Right. So we add a valid left right. We could then do all the permutations to make these lookups trivial.
Correct.
Mm-hmm. Yeah, I don't think it's actually that far from completion. I think it's basically.
But I thought that 2 episodes ago. Go ahead.
That's true, but like it is really reduced to this oracle, right? It's just reduced to these 3 functions, making them correct, and finding some data representation for the oracle to make that convenient. Because all the other code is theoretically written in bug-free.
Okay, so since we're 5 minutes over time, I'm going to go out on a limb here. We don't yet know if we're going to have a show next week. There may be some technical difficulties getting me on stream.
Upside down smiley face, exactly.
But we could leave as an exercise for the enthusiastic reader.
Send us your pull request.
PR to implement the oracle. I think I can make this promise that if we get a PR, we will review it on stream.
Yes, absolutely.
But otherwise, we're probably going to move on to a new topic in either next episode or the episode following. I'm going to hide the code machine.
Do you want to put the URL of the Git repo? It's in the Rubber Duck Engineering.
Yeah,
GitHub.
it's in Rubber Duck Eng. I have it here. What is it? Wave. It was wave function.
Wave function collapse. Yeah.
Homework is not required, but someone does homework, we will review it.
I'm also interested in all the other bugs that we don't know about.
Critique of our code is also welcome. This is generally true of all of our, PRs are always welcome. I can't promise we'll review all of them on the show, but PRs are always welcome. Because we do write bugs. I have a career of writing bugs. Any final thoughts before we part?
Not particularly. See you all next week. Thanks for coming.
See you all next week.